Unlock the power of industry-defining data with S&P Capital IQ Pro. Combine the fundamentals you expect with the data you've always wanted. The S&P Capital IQ Pro platform covers 18 million companies and counting. In addition to best-in-class financials, estimates, news, and market data, S&P Capital IQ Pro offers an array of private company data, ESG solutions, and supply chain intelligence. We've been collecting private company data for more than 20 years. Access robust coverage for small and medium-sized enterprises with transparent models and signals that can be integrated into your workflow. Integrate sustainability factors into your investment decisions using our growing range of environmental, social, and governance solutions, which bring together existing content and new classes of data. Gain leading insights into the unique aspects of ESG that matter to you. Explore our comprehensive collection of ESG data offered across S&P Global. Access differentiated insights into the risks and opportunities facing companies today with supply chain intelligence, powered by Panjiva. Gain greater transparency into global trade data with proprietary research, supply chain company profiles, and country-level analysis. Anticipate what's next with a single source for industry-defining data, so you can make decisions with greater conviction. Discover your power. Search S&P Capital IQ Pro today.
Atty Geophysical Consultants, providing expert advice for geophysical and geotechnical exploration carried out in the mining, metal sector of the materials market and energy market. Provide a wide range of geophysical and geotechnical services to environmental groundwater and engineering industries. Long-term experience in base metal exploration, pottery gold, and copper exploration, geophysical data processing, and modeling services. We have a wealth of international survey experience over the past 2 decades. Over 28 countries in some of the most remote and challenging environments. Our services: geophysical project design, field acquisition, field supervision, processing and modeling, data interpretation, industrialization surveys, transient electromagnetic surveys, ground magnetic surveys, unmanned aerial vehicle magnetic service, downhole surveys, radiometric surveys, resistivity surveys, seismic surveys. Atty Geophysical Consultants.
The Philippine Mining Club and the Philippine Infrastructure and Construction Club are professional networking forums bringing industries together and creating opportunities for the Philippine mining and infrastructure and construction industries. Networking is about giving, not taking. It is about forming trust and helping one another toward mutual goals, regularly engaging with your contacts, and finding opportunities to strengthen relationships. Networking is a great opportunity to exchange best practice knowledge, learn about the business techniques of your peers, and stay abreast of the latest industry developments. Opportunities like partnerships, invitations to events, introductions, and giving talks and presentations bring challenges that benefit and feed your career, professional development, and personal interests. Gaining the advice of experienced peers is an important benefit of networking.
Good afternoon, everyone, and I'd like to welcome everybody to our latest webinar, and I'd especially like to welcome our PMC members, PMEA members, and of course, our marketing partners to our latest webinar. My name is Kevin. I hope you have an enjoyable, informative time with us today. Very good speakers today. Just before we get going, I'd like to mention and thank our valued marketing partners for, without these companies, these webinars would not be possible. Our supporting partners: Major Drilling, Clean Earth Technologies, Hexagon Mining, Metso Autotech, Imdex, EMCEE, Cruise, Marceau and Terraflowing, First Metro Securities, Ollie Consulting Group, and Resources Comms. Moving on to our foundation partners, of course, Weir Minerals. Weir deliver end-to-end solutions for all mining, transportation, milling, processing, and waste management activities. Very happy to have Weir Minerals on board. Site skills training, Site Skills offers international recruitment and workforce solutions to companies in the mining, processing, oil and gas, and construction industries. Our principal partners, Atty Geophysical Consultants, as you saw their video previously. Advice and guidance for geophysical exploration programs being carried out in the mining and metals sector, as well as the coal sector. Atty Geophysical Consultants also provide a wide range of services to the environmental, groundwater, and engineering industries. QED, Quest Exploration Drilling, Asia's leading exploration drilling company with modern equipment, with well-trained staff. This has elevated QED to become the benchmark for international standard drilling operations in terrain that is generally typified by logistical constraints, geological complexity, and topographical extremes. Moving on to GHD. GHD has had a permanent presence in the Philippines since 1998, with over 600 professional staff spread across 3 cities in the Philippines, their main office being in Makati, 2 branch offices, which they now have in Cebu City and Quezon City. Focused on creating lasting community benefit, GHD leverages on its connected global network of 10,000 employees to provide engineering, environmental management services to key players in the energy and resources sector. And we should hear from GHD hopefully next year in the Infrastructure Club. Prime BMD offers their clients services for major infrastructure projects throughout the Philippines and Southeast Asia. Expertise, experience, and resources are applied across the industry sectors of transport, water, ports, resources, and the energy sector. S&P Global Marketing Intelligence. S&P Global Market Intelligence integrates financial industry data, research, and news into tools that help track performance, generate alpha, identity, investment ideas, understand competitive and industry dynamics, perform valuation and asset risks. The most trusted global mining sector data all in one place. That's the power of S&P Capital IQ Pro. Our industry partners, we'd like to thank OceanaGold. The Philippine Mining Club is also affiliated with the Melbourne Mining Club. ANSCHAM, the Australian New Zealand Chamber of Commerce. PMEA, the Philippine Mining and Exploration Association. COMP, the Chamber of Mines of the Philippines. PMCEE, the Philippine Mine Safety and Environment Association, and Yamaha Philippines. Our media partners, of course, are the Philippine Resources and Construction Journal. I'd just like to hand you over now to Mr. Ian Lewis, who will take you through the next part of our journey. So welcome, Ian, and can you please take care from here?
Thank you, Kevin, and pleasure to be here again today, and welcome to all our participants. I'd like to introduce you today to our MC, Attorney Patricia Bunye, is the Senior Partner and Deputy Managing Partner for Administration of Cruz, Marcelo and Terraflowing. She heads the Mining and Natural Resources Department and the Energy Practice Group. She's also a partner in the Intellectual Property Department. She's a past president of the Licensing Executive Society International, better known as LESI, from 2016 to 2017. She was the first Filipino in Southeast Asia to hold this position. She is also founding president of Diwata Women in Resource Development, Inc., a non-government organisation that advocates responsible development of the Philippines' wealth in resources. She is an active member of the Chamber of Mines of the Philippines Legal Committee and is a columnist of the Philippine Resources Journal. She is in the 2021, 2020, 2019 and 2018 list of the Philippines' top 100 lawyers and has been cited by various international law resource publications such as Chambers, Legal 500, Asia Law, among many others. Ladies and gentlemen, it gives me great pleasure to now hand you over to our MC, Attorney Patricia Bunye.
Thank you very much, Ian, for the kind introduction. Good afternoon, ladies and gentlemen. I'm very pleased to be back as your MC this afternoon. Before we proceed to our speakers, I would like to highlight the following. First, we will be issuing certificates of attendance. To those who need them, you can request a copy from Ms. Joan Falcotella. Her email address is joan@philippineminingclub.com. Next, for your questions addressed to our speakers, please type them in the Q&A or chat box found at the bottom of your screen. Please indicate to whom you are addressing your questions, and I will read them out after all the presentations during our Q&A session. So now I would like to introduce our first speaker this afternoon, Mr. Sandy Gillis. Mr. Gillis is a financial analyst working to educate clients of the stockbroker firm First Metro Securities. He used to teach finance in college for undergraduates and for Master of Business Administration students. Ladies and gentlemen, I'm pleased to introduce Mr. Sandy Gillis.
Hello and good afternoon. This is the Stock Watch about Weir Minerals or Weir Group PLC. It's listed on the London Stock Exchange, and the share price in British pounds is 1,748, and that's how you would be able to buy Weir Minerals on the London Stock Exchange. Now, you may also buy Weir Minerals in the USA via Citibank. The shares of Weir Minerals are deposited in the bank, and then the bank issues to you a depositary receipt corresponding to $12.20 per receipt. And the receipt in US dollars corresponds to a certain number of Weir Minerals shares in British pounds. So that's how US dollar investors can access the stock. The shares of Weir Minerals are denominated in British pounds on the London Stock Exchange. Some of those shares are deposited in Citibank, and then Citibank issues certificates to people who would like to invest in those shares. The certificates represent ownership of a certain number of shares. They're called depositary receipts. And that's how US dollar investors can access the investment using their currency and talking to a company on their soil. So that's the main story of what an American depositary receipt is. there is also a variant of this, which is the global depositary receipt, which means that there's a bank somewhere in the world who takes care of holding on to the shares and issues the investor a depositary receipt. Now, the share price was £565 in 2007, and then it went all the way up to 2,511 in 2014, but now it has settled to this price of 1,667, and that's still a lot of good growth from 2007 to the present. Following that green line, it represents 8% per year upward movement in the past 14 years. It's true that there was a big jump up of 24% from the low to the high, but it's more representative to measure from the beginning of this time period, 2007, to the present, and that would be approximately 8% per year, represented by the yellow line. Now, so here it is, 8% per year from 2007 till the present, and it's simply a geometric average of the price gains per year, not counting dividends. Now, of course, the question is, can the share price continue moving up at 8% per year? Well, yes, if the sales and profits are good. So if sales and profits continue to be good, then despite the wiggles in the share price, it might still proceed at an average rate of 8% per year. Now, how can shares continue to move up in price 8% or better in future years? You need to look for healthy growth in sales and profits. Okay, so the indicators are that the revenues have been growing 7% a year, which is good. And we just need to check if profits will also be healthy in the future. The past years were okay, moving up between 5 and 6% per year for the past few years. Now, for this year and for future years, one might be able to forecast that the profits may grow, for example, 5 or 7% per year, based on what the analysts think would be achievable. But then they need to check what the company is actually declaring as profits in the first quarter of the year, in the second quarter of the year, and in the third quarter of the year. So if the profits in the first quarter represent an 8% improvement over the first quarter of last year, then you're on track to hit 8% for the year, especially if the second quarter profits are still representing an 8% improvement over the second quarter of last year, and together the first half statistics are 8% better than the first half of last year, then you're on track to hit 8% for the full year this year. And that's why investors normally look at the announcements of profits every quarter to check if the full year could be also 8% per year. If yes, then you have good chances of reaching the target of letting the share price move up 8% per year. And that's why investors have the responsibility to read the interim statements, the financial statements, every 3 months or quarter, so that you can check whether the forecast for the full year is attainable. I look forward to the presentation for today. Thank you for listening. Contact me for further financial questions. I'm Alexander Gilles. I work with carillonpartners.net for financial consultancy. I also run this Facebook group on stocks and investing. Thank you and good day.
Thank you very much, Sandy. Your Stock Watch updates are always very educational. Please allow me now to say a few words about our keynote speaker. Mr. Nils Richard Steward is the General Manager, Operations and Development of Weir Technical Center, Weir Minerals. Nils is the global expert in the field of tailings handling solutions with over 30 years of experience in mining. Educated in South Africa, Nils attended the University of Cape Town, where he graduated with a Master of Science degree focusing on backfilling. From there, he went to work on mine sites for a number of companies, including Anglo American Gold and Uranium, specializing in underground support, backfill, and tailings systems design and operation. After developing a number of backfill systems, high solids concentration tailings pipelines, and fly ash disposal systems with Golder Associates, Nils and his team moved to Weir Minerals and opened the Weir Technical Center. Nils has developed a full range of services, laboratory, instrumentation, settling testing, and pumping models to assist in the effective design of Australia's largest slurry pipelines in recent years. This business continues to grow and expand to global customers under Nils's management, both as a service to Weir customers and research center. The main focus of research work by Nils and the team has been the development of an innovative tailings dewatering process termed Terraflowing. This process aims at improving tailings storage and safety, as well as developing tailings as a resource and a practical pathway to a circular economy in mining. Before Nils begins his presentation, we will have a brief introduction to the company by his colleague, John Mitchell. John is the Business Development Manager Asia for Weir Minerals. He has over 35 years of experience with Warman and Weir, providing customer field support in the Asia-Pacific region from Mongolia to Papua New Guinea. A frequent visitor to the Philippines, he is now based out of Weir's Asia Regional Office in Kuala Lumpur. Ladies and gentlemen, let us all welcome John Mitchell, to be immediately followed by our keynote speaker, Nils Richard Steward.
Thank you, Patricia, for those words. I will be running my presentation off my computer, so I'll just switch to share screen. Okay. I trust you can all see the Weir presentation now. So it's a great pleasure to be able to talk today to the Philippine Mining Club. And we'd like to thank you for this opportunity. Hopefully in 2022, we'll be able to do a bit more face-to-face when we get back to the new normal. But today we're going to do just a very brief overview of Weir's vision of sustainability and a little bit of explanation about Weir for those who are not 100% familiar with Weir. And then we'll move on to Nils' presentation. I will only take up about 10 or 12 minutes. So who's Weir? I've been to many mining club luncheons around Asia, and as soon as they see Weir Minerals, sometimes people say, which mines do you operate in? Well, we like to say we operate in all of them. So we actually started, well, we have a division in minerals that focuses on mineral processing for engineering products, services and solutions. The two old chaps that you see on the picture here are George and James Weir, who started the company 150 years ago to this year. So we're actually been having celebratory functions this year, which has involved some of the royalty in the UK. So our company is based out of Glasgow, where they started off, and they became famous because they invented a direct acting boiler feed pump that was used for steamships. It revolutionized the steamship industry, and it allowed a greater range of ships to be driven by coal. The company that we purchased, Warman International, back in 1998, which of course acquiring the Warman pump, part of the group. That's when I came along with the Warman group, because I was part of Warman International. Weir is, the Warman pump was the first rubber-lined slurry pump in the world. which was developed over 80 years ago and is continuing to be developed and innovated. The ESCO ground engaging business was acquired by Weir in 2018, which gives us a great insight into more wear-resistant materials technology and gives us end-to-end mining solutions. I think it's already been covered that our revenue and the size of our business is around 4.5 billion market capitalisation. We're fairly proud of the size of the way Weir has grown over the years. It puts us into the FTSE 100 club on the London Stock Exchange. And there are only two engineering companies in the FTSE 100, Weir and Rolls-Royce. So Weir is quite a global manufacturing and supply chain business. We have our 15,000 staff spread right the way across the world. This enables us to get geographically close to our customers to provide that after-sales service. It also has been great, especially during this COVID time, giving us a great degree of supply chain flexibility. In Asia, we operate out of our regional headquarters in Kuala Lumpur. And in the Philippines, we have a fairly large staff, which is led by Nico Satya, and that includes our area support staff, our rebuild and our rubber lining teams. So the Weir portfolio of products with the acquisition of ESCO gave us more of a footprint in the mining side, the pure mining part of the business, where they are the #1 ground engaging tool manufacturer in the world. With comminution, our Enduron high pressure grinding rolls are the #1 in the world. The Warman slurry pump is by far the #1 used slurry pump globally. And of course, in tailings management, which Nils will be talking more about, we have our GEHO positive displacement pumps for pumping high density solids, concentrated slurry. So this gives Weir an end-to-end solution for mineral processing plants, right from truck body linings right through to the tailings systems. Now, with all the different technologies, we have a wide range of erosion and abrasion resistant materials that have been developed for each product. And we're able to apply those to our existing customers for the benefit of alleviating pain points and wear points within their plant, not just purely within our pump or hydrocyclone or crusher products. So we're doing a lot more with piping and drop chutes, etc. Some of the brands that are under the Weir company portfolio, some of them will be very obvious and known to you. Familiar brands like Linatex and Multiflow, and then a few other brands and maybe you may not have been familiar with in the past. So Weir's vision for sustainability. It's opportune moment that with the COP26 conference about to kick off in Glasgow, Glasgow is the home of Weir. And in fact, we had a webinar last night from our CEO and all the board. And it's at the core of our business, sustainability. And I think there was a comment made recently by the US Special Envoy on the Environment, John Kerry, where he mentioned that governments can't do it alone, that private companies also have to get involved and contribute to sustainability. So to sum it up, we strive to make our customers more sustainable and efficient. And of course, sustainability and efficiency can also move to improve profitability. It's at the core of our purpose and the heart of what we do. At this point, I'd like Joe Paul, if he could run a short video on our Weir vision for sustainability, which would be a better summary than anything else I could say at this point.
Sustainability is a big challenge for all of us, and the world's primary industries need to be part of the solution. That's why the Weir Group is innovating new technology to enable the sustainable and efficient delivery of the natural resources that are essential to creating a better future for the world. Because many natural resources are finite, it's critical that we focus our innovation on helping our customers become more sustainable. We are engineering this transformation in the industries we work in. Reducing the world's dependence on carbon requires more electrification and greater use of alternative energy supplies to power our vehicles, heat our homes, and reduce greenhouse gas emissions. Yet renewable technology usually requires metals, which are a non-renewable resource.
That's why innovative technology is so important to this solution. An electric vehicle uses 4 times as much copper as a traditional car, and Weir Group's technology helps process most of the world's copper. So you can see why a focus on making technology more efficient is critical in making mining more sustainable. We want to provide solutions to our customers that meaningfully reduce water and energy use and minimise waste.
Weir Group's Enduron high-pressure grinding roll is 30% more energy efficient and uses far less water. Our new Terraflowing technology can turn tailings waste into a safer, usable resource. We're even working on solutions which will reduce truck journeys in mining by pumping ore from deep underground.
We strive to make our customers more sustainable. It's core to our purpose and at the heart of what we do. But to be credible, we have to make Weir more sustainable. And that's why we've signed up to a 50% reduction in our own CO2 emissions by 2030. And of course, sustainability is not just about the environment. It's about having a positive contribution in the communities and to other stakeholders all over the world.
That means prioritizing the safety and well-being of everyone who works with us. It means nurturing our unique culture to be the place that our people do the best work of their lives. It means inspiring people from all backgrounds to become tomorrow's engineers, creating the sustainable solutions that our world depends on. We have developed a holistic strategy for sustainability with targets that are ambitious and achievable. We're focused on where we can make the biggest difference. We share a single vision with our customers, making mining more sustainable.
And so at this point, I'd like to hand over to Nils Steward, who will continue with his presentation on tailings as a resource.
You're on mute. Okay, there, sorry. I was having a problem with technology and trying to unmute myself, which I've now managed to succeed in doing. And yes, Patricia, thank you very much for that introduction. Made me feel very, very good about myself. And now I'd like to thank the Philippine Mining Club for entertaining us today. And I hope that I'm going to present to you something that'll be stimulating and will bring forth a lot of discussion about the opportunities that exist within the mining world regarding tailings. As a first slide, just to give you an idea of the magnitude of what we deal with in terms of tailings. Tailings being the material that's left over after we've actually got the mineral that we're after out of it. And this picture that I've put together here is to give you an idea of the scale for, say, a gold operation or any operation where you're getting 3 grams per ton of a material out of your tailings mass. And once you've ground the tailings up, there's a bulking factor. And you can see that based on the assumption of a 3 gram per ton value and a 1.6 kilograms per cubic meter volume of material left over, this is the size of the material, if you could imagine that as a cube. And this little red dot is what is actually the valuable product taken out. So we can land up with this huge mass of tailings that needs to be stored. And if we don't store it, we need to be able to do something about it. And that's hopefully what we're going to look at unpacking today. So tailings has increased with time. As you can see here, early 1900s, we were doing hundreds of tons per hour. Now we're up to dealing, hundreds of tons per day. Now we're up to dealing with hundreds of thousands of tons of tailings per day. So there's been a significant increase in the amount of tailings produced. And that is because grades have gone down. That's because demand has gone up. And so the challenges for us as miners is how do we store tailings safely for the period of time that is expected, which was sort of around 1,000 years, and we can now start to consider that we've got to do safe tailings storage design in perpetuity. Can we recycle tailings? Can we reuse tailings? Can we produce no tailings at all? And these are the challenges that we're going through in industry now. So traditionally, we've had very much linear thought, and in many instances, we're still struggling to get out of that linear thought mold. And that really was, we mine the material, we crush it, we get the ore out, and we go and store the tailings in a traditional tailings dam. And the linear thought on that is that what we're looking at is we're looking at removing more water from it. So we're looking at removing more water to, number one, recover the water, and number two, to be able to have a more stable structure behind. But that is still doing the same thing. We can reuse tailings. There is the opportunity to reuse tailings as backfill and put that back underground. And if we have a look at that and we're able to fill our entire mining operation, we can get about 60% of our tailings underground maximum. And you can see the size that here, this tailings dam being 60% smaller than the other one. So there is a reuse opportunity. In terms of moving to revolutionary thought as opposed to evolutionary thought, what is it that we can do to reuse, recycle, repurpose tailings? And how much smaller can we make that tailings dam, or actually just do away with that tailings? What have we not developed as of yet? And this is where we come to this tailings as a resource concept. There's a lot of conversation about it. It certainly is something that's spoken about a lot, but it's not actually gaining traction to move. There are many things that you can do with tailings already, whether that's building blocks, pavers, spraying shotcrete, whether it's casting it, or making it as a foamed product. Many of these products have been developed in the mining industry, most notably Anglo Gold. I've been involved with that over the last 30 years with Anglo, when it was still Anglo American Gold and Uranium, to Anglo Gold Ashanti. Very innovative, looked at developing cementitious products out of mine tailings to put in their underground supportings. Eldorado Gold, we'll have a look at some things that have been done there. And most recently, Vale has been producing a block with a tailings component. Tailings have been used in South Africa extensively in the manufacture of clay bricks, with strengths ranging anywhere from 55 to 150 megapascals. I've shown you a small picture on the side here of work that we did, again, 25 years ago, on having a look at the kiln firing of tailings, bricks, 80% plus tailings, that were then extruded in a traditional brick manufacturing method and fired at 1,100 to 1,180 degrees centigrade. So it is possible to do other things with tailings and look at the producing products that can be used as functional structural members. If we look at an authoritative concrete technology journal such as Fulton's, one of the things you get out of Fulton's is that sands such as we have in mining these days, i.e. less than 300 microns in size, have got great effect upon concrete products and how they mix and how the workability of these. What is very interesting is that if you have a lot of minus 300 micron to 150 micron material, it entraps air. But if you have less than 75 micron material in it, it actually prevents that air entrainment. We obviously have lots of minus 75 micron. And one of the other things that Fulton notes is that an increase in dust component, which is minus 75 microns, actually lends itself to strength. And all of these part of our mine tailings. If we now extrapolate this to the real world, ultra high performance concretes, also called reactive powder concretes, is becoming a very well established product. It's actually been sold for many years under the trade name ductile by Lafarge, and it's a combination of cementitious materials and sands. Those sands typically being 150 to 600 microns in size, and a filler between 5 and 25 millimeters in size, of course. And this is well within our mine tailings regime. If you have a look at some of these things here, this is the Schillen Viaduct in Switzerland, which is manufactured from ductile. Here we have the Priest Bridge in Seoul, which again manufactured from ductile. Because of the fine nature of this product and its extremely high strength, being in the order of 200 megapascals, you're able to make these extremely fine structures and these architectural units. In 2011, the United States Department of Homeland Security Science and Technology Division actually held a conference on how to commercialize this ultra high performance cement, as it's called, further in the marketplace. So where are we with our typical tailings particle size distribution envelopes? And just keep this in mind that we're looking at 100% below 600 microns. We're looking at D50s of 50 to 100 microns. Sorry, D75s and D50s of 15 to 40 microns. So it's particularly fine. What I've done is I've put together an envelope here of materials that we've worked with, from the gold, nickel, copper, typical tailings, and their particle size distributions. And we'll be only investigating these size distributions. We have done work with iron ores, and we'll talk about that later. So, tailings as a resource, what can we actually do now? We can actually produce a large number of products, but there needs to be a requirement, and there needs to be a market, and it needs to be accessible. And this perhaps has been part of what has held us back. Each site is different with its opportunities, and no one model fits all sites. But we're able to make fired products, as we've discussed. We can make basically clay bricks out of tailings. We can recover minerals that can be used in other resources. So we leave behind silver, we leave behind magnesite. We can actually build tailings dam structures. So the actual sand structure that contains the tailings can be built out of the tailings, obviously, itself. And this is done extensively throughout South America. We can manufacture backfill from it, paste backfill, as we all know, a high density, high solids concentration cemented product. We can produce hydraulic fill from it, which is a product that dewaters. And there is obviously the concretes, concrete products, bricks, pavers, etc. Sprayed concrete, which we know as gunite, some of us, and shotcrete as others, used extensively underground for underground support. We can make ultra high strength concrete, as we've already seen. Lafarge has got their product ductile, and we can look at cellular concretes, or those foamed concretes. Now, it's easy to talk about it, but what's actually being done? So if we have a look at this particular product is my personal favorite. This is a product that was produced out of mine tailings for the Anglo Gold drill and fill mining technique in South Africa, where what they did is they drilled out the gold reef. So they would drill a hole between 500 and 900 millimeters in diameter at a dip of around 20 degrees and over 30 meters. So you would remove that rock and basically just taking out the gold channel. And what they wanted to do was replace that with essentially rock. So they wanted to a cement product that gave around 200 MPa UCS, uniaxial compressive strength, and an elastic modulus of 38 to 42 GPa. We actually achieved this with their tailings from the mine, and we transported this product in two components, one through a pipeline 3,500 meters underground. We took the cement down separately. We combined the components underground and pumped these with positive displacement pumps over another 1,000 meters. Now, this product is actually 85 weight% solids. Amongst its characteristics is it's self-leveling. And we've got a competition at the moment going on at the WTC, where our staff are actually looking at manufacturing the highest strength concrete that they can manufacture. And at the moment, the work is running at 95 megapascals within 48 hours. And these are from gentlemen who have no cement technology background and are following what they can actually find through the literature. And we'll see who wins this competition by the end of November. The other product, sprayed concrete. We've done this again on various gold mines, both on surface and underground. And it's 100% tailings. There's no aggregate in this. What's very interesting with this wet shotcrete is that it has very, very low rebound, as you can see from this, and compressive strength between 25 and 55 MPa can easily be achieved. Energy absorptions, anything up to 1,800 joules, depending on what type of fiber you use in it. We tended to use polyfiber. And an FNOC result, or a French pan result, some people might know of it as, is about 2.5 to 3 times the energy absorption you would get with an Australian round determinate panel. You do have to use accelerator with this. So again, we've actually replaced a sand, we've replaced it with a tailings, and we're actually able to achieve up to 40% savings in costs to the mine by utilizing their own tailings. Here's one that's relatively simple to achieve. This is a road that was cast on a mine site for a mine. This road washed away every year with the heavy rains, and that water, together with the mud from the mountainside, would wash into the tailings dam. And this would obviously not lend to stability in the tailings dam. These pictures that you're seeing here are of the road after 4 years. Now, that road has now been there for almost 6 years. And you can see the slipway that was also built to take the water around the tailings dam. So the tailings dam now no longer saw the water. So the actual concrete road manufactured from tailings served two purposes. It stabilized the tailings dam, and it actually provided a constant roadway through the wet season as well. The wear characteristics of this product were superior to the equivalent 25 MPa aggregate-based concrete. A lot of this had to do with the aggregate-based concrete as it wore the aggregates would pop out of the concrete. In terms of the tailings-based concrete, the aggregates are less than 300 microns in size. So you don't get a great loss, and then that pit that is formed that the rest of the corrosion or erosion can take place in. Flexural strengths were very similar, and shrinkage was very similar to the aggregate-based concretes. There are two things that we could do here. Number one is that it could be placed as a liquid, as a slurry, and allowed to, with time, to strengthen, float it out naturally. The other thing is that if we take out the superplasticizers from it, what we landed up with is a product that can actually be roller compacted. So we're still able to deliver strength into the order of 25 to 60 MPa, even if we actually take out the superplasticizers and roller compact it. What I've done is I've put another slide in here of exactly this roadway, because I think it's quite interesting. It's low-hanging fruit and really delivers an impact to you about what can be done. This roadway, as you can see, was essentially cast with tipper trucks. The tailings and the cement were manufactured in the shotcrete plant that this mine had, delivered in tipper truck, pushed out with rakes by men, and then floated by traditional methods using essentially long planks that were then used to float the material back. And this gives you an idea of the trucks that then were trafficked over this road over the period of time that it was in operation. And you can see the tailings dam in the background. I just added that in to give one more of an idea of the construction. In terms of cellular concrete, again, one of the tasks that we were set was to be able to produce a barrier to fire underground. And typically what was used was concrete foam blocks that were actually carried underground and used to block off various haulages. We were able to manufacture a sprayed cellular product. So it's just tailings, surfactant, and cementitious binders. And we actually sprayed it through a nozzle with the accelerator at the end, and we're able to spray it directly onto vertical surfaces. Could be used as walls, insulation, blocks, and we're able to achieve strengths up to 5 MPa. This sample here indicates exactly how cellular it is and how lightweight we can make it. That block floated in a bucket of water for 4 years, and I'm very sorry that I actually threw it away. I think that it would have been good to have still around today to show the stability of the product. In terms of copper, platinum tailings-based strengths, what we've got here is we've got two products. This specific one up here is a local Australian copper-based concrete, and this is a range of products that we manufactured from platinum tailings. And we're able to vary the strength in exactly the same way as you do with typical cement technology, cement type, and the rate of addition, the superplasticizers used, and the superplasticizers are the real change that has taken place in the mining, in the cement and concrete industry. Ductile is possible through superplasticizers. The strengths that we've achieved with the flowable concretes underground that give 200 MPa and a self-leveling were only achieved through superplasticizers. The water cement ratio, again, varies the strength. The lower we get the water cement ratio, typically the higher the strength. Tailings particle size distribution is very important. In many instances, we need to actually blend the cements and the hydraulic and latently hydraulic binders, so that we can get the best packing that we can get to give us that strength. And as with any cement technology, the trial mix designs to prove the product are the way to go. Just to give you some idea of price, people will be saying, well, what do these things cost? So we've got typically two strengths here. This is in Australian dollars. So you can put that into your mind in Australian dollars, Australian cement prices, Australian plasticizer prices. But typically we're looking at a 45 MPa blend of anywhere from $120 to $150 a cubic meter, and a 70 MPa blend from $160 to $195 a cubic meter. Obviously, depending on where you are, your cements are going to cost less, etc. When we have a look at a 200 megapascal blend, we're looking at about $1,000 a cubic meter. So again, huge flexibility over what we can do. And you can see in every instance, I've put the particle size distribution up for you to take note of. So what's the problem? The problem is that when we look at tailings, we view it as a single volume. We view this huge mass as a single particle size distribution. Essentially, we see it as an overwhelming, unusable mass of material that we have to store and look after in a safe, sustainable manner in excess of 1,000 years. We don't see the opportunities because we just see this huge mass of tailings. Essentially, we cannot see the trees for the forest. So, what is possible? You've seen a lot of things are possible. And if we view tailings as a range of particle size distributions and not just a single particle size distribution, we start to be able to see the trees. If we separate out a coarse fraction, the less than 600 microns, and we actually use that in cementitious components, we can actually pull out 60% of the material and make essentially cementitious components out of it. But again, market, again, location, we've got to see what can be done. If we have an intermediate size range, less than 300 microns, a D17 or 17, a D50 or 17 microns, that constitutes about 20% of the tailings, and is ideal for actually constructing construction boards out of it. Gypsum is not dissimilar to tailings in terms of the particle size distribution, and what we've managed to achieve with foam tailings is not dissimilar to what actually is achieved with gypsum board. So we're able to start saying, well, maybe we can actually manufacture a board out of foam tailings. It'll certainly have fire resistance. It'll certainly have the insulation capacities. What about a fine fraction, 100% less than 30 microns? Well, fines are used in fine fractions less than 30 microns are used in plastics to extend plastics. So whether they use different materials to get different properties out of plastics, or whether they just use it as a filler, plastics have fillers in them. Very interestingly, and it's part of the next slide, is that there are products out there manufactured today that are papers and packaging that is actually manufactured from not tailings, but from ground rock. Whilst it may be a very particular ground rock that is used because they wish to achieve a particular paper quality, that doesn't necessarily mean that we have to use our tailings to do that. We could actually manufacture packaging, which anybody who buys a television set, a video player, goodness gracious me, buy a set of headphones these days and the packet is this size and the headphones are this size. There's a lot of packaging and a lot of paper in these things. So that brings us to, is there a tailings as a resource solution? Is there something that can lend itself to circularity? Is there something that can lend itself to being able to reuse all the tailings? And this is the crux, recycling and reusing. There's some systems that can be thought as low-hanging fruit in terms of our mining. We can look at safe storage, and we're looking at that in terms of dewatering opportunities. They have environmental benefits. We get water recovery. We have to have a stable structure. There are other opportunities in terms of, depending on where your operation is, can we actually transport the tailings to the coast? Is there a need to transport the tailings to the coast? Can we recover energy while we're doing that? Is there products within the tailings that we could recover through in situ leaching? If we're going to transport the tailings from site to another place to do something with it, can we put in the enzymes that are going to leach that material out? And when it's transported 20, 30, 40, 100 kilometers, can we recover the leachate and those other products? Are there alternative minerals? I had a discussion not yesterday, the day before, with a gentleman whose mine happens to have an overwhelming amount of magnesite within their tailings. Calcined, dead burnt, is actually a very stable cement that produces very high strength in a very short period of time. But you need to get the necessary people together to get it from the one place to the other place to the market. If we have a look at where we can go in the future, we start to see the interesting opportunity in terms of tailings as a resource and achieving circularity in terms of mining, in terms of infrastructure development, social upliftment, job creation, and a license to operate for the mines. By getting engaged in what we can do in building structures, masonry products, roads, how we can get into plastic recycling, taking tailings into plastics as a filler, manufacturing, papers and packaging. All of this, however, requires collaboration. We require the collaboration of governments together with the collaboration of the mining, because one has got the entire infrastructure development, social upliftment, and the other has the license to operate and the ability to create jobs. And we need, obviously, the technology and the industry to come together. So this is something that is not going to be able to be achieved without the collaboration of all of these organizations and parties. So when we look at these possibilities and we look at the fact that we need to separate this out into different size ranges so that we can see the trees, i.e. the fillers and packaging as we've discussed, the boards and cellular products that we've discussed, the cementitious products, whether that is building breakwater structures at a harbor, railway sleepers, roads, schools, houses. All of these are possible with tailings in many different formats, not just cementitious, but also in terms of plastics and also in terms of actually firing products. So we need to have a look at how can we achieve essentially the trees, the different particle size distributions. And this is where I move to Terraflowing, the dewatering process that's being developed within the Weir Technical Center of Weir Minerals, and is still in its embryonic stage. We have gone a long way down the road in that, and I will actually show you a pilot facility that we're starting to operate. But it's a flexible dewatering process that makes tailings as a resource possible. Not only tailings as a resource, but if you're looking to produce a stable product for storage, you can do that as well. Essentially, we have three stages. The first being a primary cycloning stage, where we then take the overflow from that to a secondary cycloning stage. And the secondary cycloning overflow is taken to the final cleaning and dewatering of what is a very fine product. And that can be through centrifugation. It can be through any other methodology. If you are a brownfields operation, you may wish to use your existing thickeners to do that. But we land up with three product streams. The initial product stream is we can modify that initially straight for the manufacture of a tailings dam embankment, and take the following two streams, combine them, and dispose of them as a stable, thickened tailings within that. And we'll discuss all of that as we go through here. So we can have this combined storage strategy. We can actually have the value added use and the tailings as a resource strategy, because we produce different particle size distributions that can deliver different products. In terms of particle size distributions, these are the envelopes of the products that we've dealt with. We've dealt with gold, copper, nickel, which basically forms the blue envelope. We've dealt with iron ores from a number of operations, which basically fills in the green envelope. So everything that we have evaluated falls within these envelopes, and all the work that we've done, of which I'll give a brief overview now, has actually been for dewatering purposes. We have not gone further than just looking at producing the higher solids concentrations that are pumpable. So when we have a look at our primary cycloning, we started off in our test facility. We have a fully instrumented cyclone test rig at the Weir Technical Center. So we measure mass split in real time, and we're able to fit different cyclones into it. And the test facility is fully instrumented to measure everything in terms of flow rates, pressures, etc. And all our equipment is on variable frequency drive, so we can also vary the flow rate. I need to state quite clearly that these cyclones are not operated in the manner that you traditionally operate cyclones, as you'll see as we go through. With our primary cycloning, we're able to achieve an underflow solids concentration from the cyclone of between 73 and 80 weight percent, depending on the particle size distribution we're trying to achieve. And we get between 40 and 60% recovery of the total tailings in the underflow. Depending on what we're trying to achieve, we can get particle size distributions anywhere from 15 to 35% passing 75 microns. The reason I mentioned the particle size distributions is that when you're constructing a tailing storage facility embankment, the train of thought currently is that you want to have an underflow particle size distribution of 20% less than 75 microns. This is only a guideline. Obviously, your underflow product has to release the water. It has to be compactable. It has to achieve certain strengths. And all of that is a geotechnical assessment. But typically, 20% passing 75 microns. And here you can see how we achieve different particle size distributions with the levers that we pull: flow rate, operating pressure, what we inject into the cyclone, which is part of our innovation, and then again, vortex and spigot sizes. Just to give you a flavor of what comes out from, or what is possible from the underflow of our 150 cyclones, this is typical gold tailings, 100% below 300 microns. This is the primary underflow at around 80 weight percent solids. Now, the problem, obviously, with the test work in a 150 millimeter cyclone is that we're only getting around 40 cubic meters to 80 cubic meters per hour through this. So if we were going to build a facility to deal with 10,000 cubic meters an hour, we'd have fields of cyclones. So what we've been doing over the period of time we've been developing this is having a look at scaling to larger cyclones. And we have scaled this to a 250 millimeter cyclone with a flow rate through it of 220 cubic meters per hour. And this gives you an idea. We have achieved exactly the same underflow conditions of concentration and particle size distribution by matching cone ratios, which is the ratio of the vortex finder to the spigot. So we have a huge number of levers that we can pull with Terraflowing in our primary cyclone to vary the product outcome or maintain a constant product outcome from a variable feed, because we have all these levers to pull. Just bear with me a moment, my computer's just catching up with me. So if we go to the primary cyclone overflow, we obviously now have a dilute product, and we need to thicken that and recover those tailings. The first work we started with was with a 100 Cavex cyclone, and this gives you an idea of the underflow solids concentration. Again, owing to the method that we operate the cyclone and what we inject into the cyclone, we were able to achieve up to 74 weight% solids concentration at 40% of the tailings recovery. So this process now delivers another 2 streams of particle size distribution. As you can see, we've got the secondary cyclone underflow and the secondary cyclone overflow. And lo and behold, the secondary cyclone overflow is 100% less than 30 microns. Obviously, I've fiddled this whole thing around, so it's worked out that way. One interesting point is that if we take the secondary cyclone underflow at 74 weight% solids, and we take the primary cyclone underflow at 80 weight% solids, we start to deliver a flowable product at around 76 weight% solids. Now that is what is used for paste backfilling, and we haven't used any vacuum filtration equipment. So we're able to produce a paste backfill without a vacuum filter or vacuum filter belt in sight. Again, bear with me, I'm just having slides catching up here. We now have this very fine secondary cyclone overflow. It's dilute, there's a lot of water. We have a methodology of being able to pull out around 45 to 65% of the residual water before we put the product into the centrifuge. So we're able to reduce the volume of material going into the centrifuge and thus reduce the number of centrifuges and power draw that would otherwise be necessary. So what you see coming out here is a centrifuge pulp in the order of 60-65 weight% solids. We get incredibly good centrate quality as our water. You can see from the jar here, that is typically what our centrate looks like, and you've seen what the actual pulp itself looks like. We get around 0.2% to weight% solids concentration in the centrate, which then means that that water can go straight back to a metallurgical process. If we flocculate the process, we get the 65. If we don't flocculate it, we actually get a higher solids concentration in the pulp, but we actually get a higher solids concentration in the centrate as well. So now we've actually got our 3 particle size distributions. We've got them in forms that we're able to deal with them immediately, whether we're manufacturing cements, whether we're actually manufacturing fillers, whether we're going to foam them. If we continue just looking at this as a mine storage opportunity, what we can do is take all 3 of those underflow streams, the primary cyclone, the secondary cyclone, and the centrifuge pulp, and we can combine those. And if we combine those, we recover around 82% of the total water in the tailings, assuming that the tailings came out of a thickener at around 35 weight% solids. So, sorry, out of the met plant at around 38 weight% solids. So what we're producing by combining all 3 of them is a very stackable product. And we're able to produce that at anywhere from 70 to 78 weight% solids. If we alternatively take out the primary cyclone stream and we use that to manufacture a tailings dam embankment, which we're trialing at the moment. So what we've done is we now make the assumption we've taken out the primary underflow, boof, it's gone. We're using it to build the tailings dam embankment. What we now do is we take the secondary cyclone underflow and we combine it with the centrifuge pulp, and we get a product that has got this kind of fluidity. That is around 64 weight% solids, okay? It's pumpable with centrifugal pump. So we can take this stream and we can store this within the tailings embankment that we have constructed out of the primary cyclone underflow. Now, there is a benefit that we have seen from doing this, and I need to explain this a little bit more detail. Here is the particle size distribution of what you're looking at now. So it's 100% below 50 microns. We made a placement inside our warehouse of this product. We measured the yield stress with time, and after about 2 weeks, we were looking at about 600 Pascal yield stress, which means it wasn't flowing anywhere. If you look at this small portion over here, that portion there is that sample there. We left this outside in Melbourne weather for 6 months, which meant that it saw very low temperatures through winter. It saw very high temperatures as well. It saw a lot of rain. What happened is it did not dissolve. The surface of this product, owing to the very fine particle size distribution, possibly owing to the nature of the flocculation, owing to the way that it desiccated from the surface as opposed to losing its water from the bottom, it has produced this hard, dust-free surface. We have created this hard, dust-free surface on more than just this product. It is a function of the process. It's a function of the centrifuge and the secondary cyclone underflow, and this very fine particle size. When we have a look at these products, this is the primary cyclone underflow. These are the pseudo shear diagrams. As you can see, we're pumping these products in what would be termed the laminar flow regime. And we get, when we do the test work in the test facility, that you can see in this area below, where we pump these products through the tailings pipelines and measure the pressure gradients and the losses, we're able to develop these relationships that allow us to design pipelines and size pumps and size the size of the pump and the type of the pump needed to deliver these products over distance. So depending on the distance would determine whether you would require a centrifugal pump or positive displacement pump. So all of these products that we're producing through this Terraflowing process for mine sites can be pumped with some form of Weir pumping system. If I take us a little bit further now, to achieve this successful tailings dam embankment construction, one has to do the test and the trial work. And this test and the trial work is underway. The objective being to deliver the correct PSD onto this dewatering pad that has been constructed specifically for it. So we want less than 20% passing 75 microns. We want to compact this, and you can see there's areas that have been compacted. We want to get samples of this to ensure that it meets the necessary particle size distribution, permeability, and compaction. We want to get a good concentration underflow so that we have less water recovery that we have to reticulate back. And obviously, we want to get a good number of solids out there. In this instance, we obviously achieve our 20% passing 75 microns. This gives you an idea of what the product looks like when it's pumped. Sorry, let me get that out of your way. And if you look to the right, in the right-hand picture, you can see the granularity and the coarseness of the product as it's being moved around by a bobcat. and the product is delivered at 74 weight % solids concentration, and we're recovering around 45% of the total tailings, which is more than enough to build the tailings dam embankment. At the bottom here, whilst we have not done a lot of work in this area, you will note that this secondary cyclone underflow and pulp, centrifuge pulp, combined pulp, when deposited on site in situ, has again desiccated and formed this hard crust, which I've got samples of this in our laboratory that we're keeping an eye on. So we're doing very much in situ what we've actually done on site, which suggests that as a tailings storage methodology, Terraflowing can also meet that, besides giving you the opportunity of investigating tailings as a resource within your organization. So when we have a look at this, what are the benefits of Terraflowing? One, definitely water recovery. Two, tailings as a value proposition. Having a look at what else is there that you can do because you have a different particle size distribution capability. Improved safety in your tailings dam. Sand tailings dams have proven extremely successful in seismic areas in South America. There is no doubt that they have withstood very high seismicity. All of this is well documented. Environmental improvements. We get to recover more water. And if we're correct, and so far we've repeated what we've done in the laboratory with the secondary cyclone underflow and centrifuge pulp, we produce a hard dust-free surface. Tailings dam with no dust. There's a significant saving and improvement on the environment there. If we go tailings as a resource on a small scale, just for the mine operation, mine roads, whether those are haulage roads, whether they're underground roads, whether they're local community roads. If we have a look at the decreasing cost of shotcrete and underground support in those areas, just because I've mentioned concrete roads and shotcrete does not deny the fact of roof bolt grounds. So there are lots of circular economy possibilities here. The societal acceptance possibilities of being able to uplift local societies, which then gives one a license to operate. Infrastructure development, as we've discussed, roads. Improved design, construction, operation, closure, and rehabilitation of TSFs because of the stable nature of the structure and because we actually are putting a dewatered product into the tailing storage facility. Rehability improvement opportunities during operation, looking at being able to close out a tailings dam whilst you're actually operating. Job creation in terms of whether we're going to make blocks, bricks, look at the fillers of plastic. I'd love to share the ideas of recycling plastics with tailings with you. Improved risk management, risk mitigation, and of course, safety, safety, safety in terms of our tailings operations and tailings storage going forward. Well, that's it from me. I hope it hasn't been too long or too boring. I'm going to hand this back.
Thank you so much, Nils, for the very thorough and interesting presentation. I'll do my best to manage the remaining time. And I was struck by what you said at the very beginning of the presentation, where you described tailings as a valueless problem material, but you took us through all the possibilities of tailings being a solution. And what also struck me was your description of how it can contribute to a circular economy. Perhaps you could share success stories in countries where Weir has a presence of how this is really a possibility, because this is something that the Philippines can learn from.
I'd love to be able to share that with you. All I can share at this present juncture is a picture, a roadmap, an opportunity, and the fact that we've actually managed to produce these products. I think, Patricia, that It's now. Time is now. The concept of having a pile stuck out in the background for over 1,000 years is going to die. And what we're doing is we're delivering these opportunities and hope that we can work in conjunction with mining houses and governments to deliver on this.
Thank you, Nils. One question posted in the Q&A box, and I hope if there are any more questions, please do post them. This is from PMEA President Joey Ison. How do you deal with the presence of sulfides in the tailings, which may be a source for acid mine drainage, or AMD?
Absolutely. So sulfides are a problem that have been known for an incredibly long time, primarily because when we've been manufacturing backfill, and I've been involved heavily in this for the last over 30 years, sulfides destroy the cement reaction, the hydration reaction. But what we find is that by blended cements, so we don't rely on Portland cements, we actually rely on slag-based cements and slag-blended cements, we're actually able to negate the, I don't know the technical words that involved in the hydration reaction, but what we do is they no longer take place. So when you typically make a Portland cement product with a sulfide backfill, you'll find that strength deterioration occurs after 28 days. When we manufacture it with slag-based cements, we've gone out to 256 days with no deterioration in strength. And what we do is we see a constant slow growth even out to that. We have done a lot of work on leaching of materials out of cement-based products. The roadway that you saw, we had to do extensive leach test work to ensure that no arsenic or cyanide was leached out of these products or heavy metals. And we went through a process of pressure filtration of water through them and actually crushing those products up, mixing water with it and evaluating the water after time. So we are able to mitigate the effects of sulfides.
Thank you, Nils. Another question from Joey Ison. He says, there are a few older TSFs with still significant metals because of lower recovery rates before. Do you intend to recover these metals first?
It's certainly not the business that we are in. We are in the business of recovering those tailings, delivering those tailings to the metallurgical process, taking the tailings away after they have been processed, whether it is again through a metallurgical process or an ion exchange process or whatever process. We'll then take that final tailings away and deal with that again. So we're the handling of the tailings products, not metallurgy.
All right. Okay. There is a question here. I'm not sure if I understand it correctly. The percentage solid your pump can convey, and it's
that's fine, Patricia.
I'm sorry.
That's fine.
Okay.
That's fine. Okay.
And it's horizontal pumping distance at 15% grade.
Very specific. I welcome that communication further through email.
All right.
I'm sure you'll make my email available to everybody, Patricia. But the short answer, pumping of the product is dependent on the particle size distribution and how much you're prepared to pay and what it is. But if you have a look at that product I showed that we're pumping 3.5 kilometers underground, that's 85% weight solids. And you could see that that was very fluid owing to superplasticizers, but it did take a positive displacement pump to pump it a kilometer. With centrifugal pumps, we have pumped coarse products, and by coarse products, minus 500 microns to probably 10% passing 10 microns. we've pumped up to around 88% solids with a centrifugal pump. So happy to engage in that discussion with the client. They just need to communicate with me on email.
We'll make sure your email address is passed on. Next question, what's the maximum capacity per unit in terms of dry solids your centrifuge can handle?
Again, dependent very much upon the manufacturer. So there are a number of manufacturers around the world. I think the largest centrifuge capability is around, it's 275 dry tons per hour. I stand open to correction on that. And again, I'm happy to correct that information through email. But the centrifuge performance is the balance between the solids concentration and the amount of water you're putting through. So you could have a very high solids concentration and low water, and you'll get performance. Or you could have a very low solids concentration and high water content, and you won't get performance, because it's all to do with the volume. So again, I'm happy to discuss that further through email.
All right. This question was sent when the participant registered. What is the difference between metal and rubber impeller/expeller?
John, I'm going to leave this one to you. I mean, it's the speed that the impellers can turn at and the amount of wear they're going to experience.
Yeah, ordinarily we would, in slurry handling applications, our first choice is always to go to a rubber impeller for cost savings, ease of handling, but generally overall lower ownership cost. Natural rubber is by far the most wear-resistant material for fine solids. As the particle size starts to increase, when we get up to above 5mm P80, 10mm P80, we then will switch the impeller from rubber to metal. And that's because of the wear mechanism with rubber. Right? When fine solids hit a rubber surface, the rubber absorbs and rebounds. These are highly resilient rubbers, and they don't cut. They absorb the impact and they recover undamaged. As the particles get larger or coarser, sharper edged, when they hit the rubber surface, the rubber absorbs some, but then undergoes some cutting. So the mechanism of wear by cutting. So when we get to larger particles, we have to go to the hard white ions. Right? When we talk about metal impellers, we talk about a minimum 27% chromium white ions, and these are around 650 Brinell hardness. Extremely hard white ions. We don't use white ion impellers in fine slurry because the wear resistance of a white ion impeller is caused by the hard phase, which is within the metallurgy, and the hard phase it forms during cooling is a chromium carbide, like silicon carbide, very, very hard, a ceramic phase, microscopically within the metal impeller. If you've got a fine slurry, it'll find the gaps between the very hard phases, and then the hard phases just fall out. So we only use the white ions when we get to coarser particles, so there's more likelihood of them impacting on the chromium carbides. So that was materials 101 wear resistant. Pretty quick summary. The other limitation, sorry, for natural rubber is impeller tip speed. So once we get to high speed pumps, we also must switch because the rubber will dilate because it's low tensile strength.
Thank you. We've reached the 4 o'clock mark, so I am down to my last 2 or 3 questions. Next is, how are you going to deal with varying feed PSD to obtain the required consistency of paste?
Okay, and the one nice thing about Terraflowing is that we have so many levers to pull that we're able to deal with variable mineralogy, variable particle size distribution by changing feed rates, vortex finder, spigots, what our proprietary injection method is. So we have a large number of opportunities to be able to deal with different particle size distributions, the same product out of the end of the two. Did you hear that?
It was slightly garbled for a while.
Shall I say it again?
Yes, please.
Okay, so because of the nature of Terraflowing, we have got a large number of levers that we can pull in terms of changing the outcome. Because we're able to change spigot sizes, vortex finder sizes, because we're able to change flow rates, and because we're able to change our injection method into the cyclones, we're able to change the particle size distribution to be more constant than other techniques such as vacuum filter discs, vacuum filter belts, which are built to only deal with what the met plant turns out. We can change what the met plant turns out because of all the levers we have to pull.
Thanks. This might be for John again. How do you control erosion of impeller for 500 microns particle?
Okay, when 500 microns, so that's just getting towards coarse sand particle size. 500 micron, we're saying that's the maximum size or the minimum size, or let's say it's D50. That sort of particle size, we could still possibly use natural rubber. Wear on impellers is a function of the speed, the tip speed of the impeller. So the slower we can run a pump, the greater, substantially greater improvement we can make in the wear life of the impeller. So if the tip speed, if the impeller is a high speed application, there's going to be wear. Wear is going to happen at roughly a cubic function of the impeller tip speed. So we will try to use the most wear resistant materials we can, but there's always going to be a limitation. So the most important thing is to try and run the impeller, the tip speed, as slow as possible. Now, the head of a pump is determined by the piping system you put the pump into. The head, the diameters of the pipe. So if you're trying to reduce wear on the impeller, we try to reduce the speed of the pump, the pressure that it's required to produce. Have a look at the piping system and see what you can do to alleviate bends, narrowing points, sources of head loss. So that's
alternatively, Patricia, we actually do pipeline design. Mm-hmm. So you can actually come to us, and if you do have a pipeline system or you want designed, we do that day in, day out as bread and butter.
Copy. Thanks.
Just on that, with what Nils is talking about, some pipeline systems, for example, it's very frequent that we will use multi-stage centrifugal pumps in series. Many times people during the capital assessment period want to use, can we get by with 2 pumps? But the impeller speed is very, very high. So you're going to get wear. Put a 3rd pump in, we can run all 3 pumps much slower. And as I said, the wear is a cubic function. So we can slow the wear rate down substantially, but it comes at a higher capital cost.
All right. Next question, how do you handle the excess water produced in producing the desired product size for recycling?
I'm not sure that I've got this question completely. So what we find is that in terms of our primary cyclone underflow and cementitious products, we really are just looking at binder addition, and we have water cement ratios that are in the order of 0.4, which is perfectly acceptable and standard for producing 25, 45 MPa concretes. When we look at the secondary cyclone again, when we add the necessary binders and surfactants to look at things like foam products, we're looking at very low strength. So again, the water cement ratios are acceptable. When we look at the ultrafines as a filler, there is no doubt that we have to look at drying those out further. So we are investigating ways that we can dry those products out. And it really is, it's getting that 65 weight % solids product down to a moisture content that is in the percentages. And that certainly is something that is going to consume energy. But the products that one is putting that very fine product into actually carries a higher value.
Thank you. I will be asking my last question. And for those who still want to ask questions after today's webinar, please contact the Philippine Mining Club for Nils's email address. Of course, we won't post it here. We don't want him to be spammed. So we'll make the address available after today. The last question.
It's a long weekend.
Yes, it's a long weekend.
And I don't want to be spammed.
Yes. Do you have any case examples in the Philippines?
No, we don't. And we'd love to have some.
Very succinct. All right. So that brings us to the end of the Q&A, and I will now hand you over to Ian Lewis. Thank you very much.
Thank you, Attorney. Another well presented webinar. And I'd also like to thank Job for his professional work in the background there. Nils, John, well done. Very informative. And Nico in the background for his facilitating this webinar. With my 30 years in the mining industry, I found this extremely interesting. And in fact, it was very much in layman's terms, understandable by most people, and very relevant in this day and age. It shows that mining can be responsible and there are benefits through responsible mining. So again, thank you very much. We're going to take a group photo very shortly, but before I do so, I'd like to mention to people that if you have subjects that you would like us to present in the future, areas of interest, please do not hesitate to contact the Philippine Mining Club or our other facilities. And again, thank you. Now, if everybody can turn on their cameras, we'll, well, actually I must forget there are certificates available, and those who would like a certificate of attendance, please contact Joanne. Right, upcoming webinars again. I forgot we have a very, very interesting one coming up presented by the MGB by Wilfredo Moncano. This is scheduled for next month. We'll be putting a notification out shortly in the next week or so, and we'd like you all to attend that. I'm sure it'll be very valuable. Again, thank you, and turn on your cameras now, and let's take a group photo. You can smile. Over to you, Job.